If you didn't get a handout, there's handouts around. There's some down at the bottom here. There might be some extras floating around. Is that a little better? Okay. I'm Eric Noble. I'm from Hastings Law School in San Francisco, and my co-presenter today is Greg Murphy, who's the president of Airwave Wireless, a company that we have partnered with in helping develop our wireless solution at Hastings. It's so incredible coming back to talk about wireless here at CALI, which is where I first got inspired to do wireless, I think probably 2 or 3 years ago, when we first saw the first presentations after 802.11b was ratified. And so it's so great to come back and talk about what we've done. And also what we wanted to talk about today was how we manage our wireless network and options that you might consider if you're thinking about wireless or if you have wireless. Centrally managing the wireless network gives a lot of advantages with security, ease of setup and configuration, maintainability, and then looking at the stats of who's using it, how the wireless network is being used. So we wanted to kind of focus kind of 2 areas. One would be for people who don't have wireless yet, and for folks who do have wireless, to look at some of the things with management. And then also some of the questions that we've talked about and dealt with and struggled with over the last 18 months in dealing with wireless. But one of the first questions I wanted to throw out was just to get a sense of who's here, is how many people already have wireless? So a lot, practically the majority. And so show of hands, how many do not have wireless yet? Okay, a minority, but a sizable one. September. And of the people who have wireless now, do you have management software that allows you to look at all of your access points? And so if I could see a show of hands. Okay, there's a few. That's good. So what I'll do first is talk about what we've done over the last 18 months at Hastings, and then Greg will talk about the technical aspects of managing wireless. First of all, some terminology and acronyms, and I won't go through all of these. It's just good to know that there are places you can find on the web that list the different acronyms, because sometimes knowing what the difference is between a WAP and a WEP will stump you. So I've given a link here to WiFi Alliance.org, which is a good site. And there's a couple others. IEEE, of course, who sets the standards. They're good. When we say WAP, I'm talking about the wireless access point. That's the radio transmitter receiver that we install in each of the spaces where we want to have wireless access. And WLAN is just wireless local area network. So the layout that we have at Hastings, Hastings is in downtown San Francisco. And by the way, if I'm dripping, I just wanted to tell you that both Greg and I are from the Silicon Valley and Bay Area, and we're not used to this weather. So the wireless layout at Hastings. Hastings is located in downtown San Francisco, in an area we call Civic Center. We're on the edge of what's called the Tenderloin. We have 2 main buildings. Our classroom building, the one on the right here, has 5 floors, 10 large classrooms with about average of 100 seats per classroom. In that building, we also have some large spaces, which we'll see some photos of, for reading rooms, seminar rooms. We've installed 15 access points in that building to cover the student accessible areas. We also have the administrative building, which is on the left here, and the primary reason that we wanted to install into that building was for the law library. We have 3 full floors that the students use for law library. We're planning on remodeling the library within the next 2 years, or starting the process now, but there was no internet access at all for the students, and that's one of the things we kept hearing from the students all the time was, when are we going to be able to access internet in the library, in the carrels? We also have dining commons in that room, in that building. And then down here is our tower residence hall. We have 250 apartments for students, and it's a 24-story building, and we're right now in the middle of a pilot project running wireless in that building, and plan on building it out. We'll probably end up having around 70 access points to cover all the floors where students' residences are. So the typical spaces we wanted to be able to cover with wireless, just common areas where students congregate in between classes, typical. This is the dining commons area over here. Very, very popular with wireless. This is the area that we did a pilot project a little bit more than a year ago, spring 2002 semester. And it's now inundated with notebook computers, students using them with wireless access. Library common areas, classrooms. This is our access point in this particular classroom. Other areas, this is one of our large reading room facilities. It holds about 200 seats. This is the outdoor patio area, which surprisingly students were asking us for internet access outdoors. And so we installed an access point, and students love to go outdoors and sit and use their computers. And finally, and why I kind of made it larger, this really was my prime reason for installing wireless, was to allow the students in the library carrels to use internet. And actually, that student was using wireless. I just took that picture a couple weeks ago, and very, very satisfied. Students are very happy. So this was the plan that we had for doing the wireless at Hastings. We first of all did a pilot project, like I said, last spring, a year ago. We installed it in the dining commons and in one area in the library. The response from the students was tremendous. We had loaner cards that we let out for the students, and we just got great response, and they just kept saying, when are you going to install it everywhere else? The nice thing about the pilot project was it allowed us to go ahead and install, with Airwave Wireless's help, the Bluesocket gateway, which we decided to use, in addition to the Airwave Management Platform Server, which is the software that we use to manage all of our access points. And so we did that through the pilot project, and so when we got to the point of actually building out wireless throughout the whole building, it was a very simple matter of just running the cabling to all of the access points, and then basically doing the configuration and installation. Site survey was important. Site survey helps you determine where you want to put your access points for the best coverage. Then, like I said, we have 30 access points in these 2 buildings, so we purchased those. At the time, we chose 3E access points.
Did you do the site survey yourself?
We did it with Airwave's help. They came in and they had an engineer who came in and helped us, and actually basically taught us how to do it. So now we do site surveys ourselves. So the configuration of the access points after you purchase them is very simple. We decided to give static IPs to our access points so that we could see them in our network management software, and you then set up just all the network stuff that you set up, subnet mask, gateway addresses, and all that for the access points, and you give them a name through the software again that Airwave provides you, and that name then sticks in all of the reports that you can run, showing usage and looking at problems, doing troubleshooting, doing maintenance, all of that. We then installed enclosures. You'll see a picture of our enclosures. I haven't actually seen an access point here at Duke. If somebody else has, I'd like to know where they are. My philosophy is I like to have technology visible on the walls to get students used to it, to get faculty used to it. So you'll see pictures. We have our access points out, and they're visible for everybody to see.
Yeah, enclosed anyway?
Yes, we do. You'll see the enclosures in a second. Setup of non-overlapping channels. Again, the Airwave software is great for helping you do that. You can configure. It's important with 802.11b that you use the 3 non-overlapping channels so that you don't have problems in interference. Those are 1, 6, and 11. Testing and configuration was very simple. You go around with NetStumbler, and you can see whether or not your access points are showing up. And then daily monitoring. And it really is a daily thing that we want to do, is to keep track of our network. So it's become another one of the things that we do to maintain our network, is to look at the wireless access points and to see if there are any problems, because occasionally there are problems with, especially with the 3E access points that we went with a year ago. We've noticed that sometimes the radios just die. And the only way to find that out is if you look at the usage on that access point. And if it's 0 and you know that there are 100 students in that classroom, then you know there's a problem with that access point. So in our site survey, we basically went around and determined where the best location was to have as much coverage in each of the locations, the spaces that I was talking about. So this is just a typical floor plan with the hand-drawn-in locations that I gave both to our facilities people who brought power to every one of these access points, and also to my cabling and wiring guys who put in the Ethernet. So these are just typical floor plans. In this plan here, this was the library floor, and this is the floor that's the most used location throughout the 2 buildings, and we ended up with 6 access points, 4 on columns and then 2 on walls, and the coverage is great on that floor. This floor, to give dimensions, is about 250 feet by 150 feet. So here's how we place our access points. Here's a classroom with an AP on the wall. These are the types of enclosures. This is a better view of the enclosure that we use. So they're just out everywhere for people to see. And that may have something to do with the fact of the huge increase in usage, and I'll talk about that in a second. Here's the network configuration. These are the access points over here. Here is the server that Greg will talk about, which they sell. And here is the Bluesocket gateway. What happens is when a connection is made to one of the access points, there's a VPN tunnel that connects them to the Airwave server. The Airwave server then does authentication through the Bluesocket gateway, which is logging to our LDAP server. We have an LDAP server on campus. And so the students can log in using the same password that they use for their email, for example. And then down here, it shows the computer connected to any web-based computer can then connect to the management server and pull up all the statistics and reports that I'll show you in just a second. This just shows you one of our racks in one of our server rooms with the Bluesocket server on top and a Dell rack computer server on the bottom, which is the computer that the software runs for Airwave. So what do we get from the management software? Well, first of all, we get all sorts of screens that we can go through to look at the status of the access points. Now, I made a very stupid mistake when I was doing this presentation. I kept thinking of what I was going to do, and I was so busy at the end of the semester, I didn't get a chance to make screen snapshots or photos, digital photos, with the students in the classrooms and the students and the access. So everything here is going to say 0 clients on this screen, and I really apologize But we were getting, we get up to 300-400 concurrent users logged into the system at one time. But this will tell you each of your access points, and here are the names that I mentioned. You can set the names up in this software, and it will tell you all the status of the access point, number of clients who are connected to it, the bandwidth, and then off on the side here it shows you your MAC address, your radio address. So if you have NetStumbler and you can't figure out what the radio address is that's showing up, you can go back here and see and associate that with a particular name. Yes, yes, you can. And in the newest version, which I don't have up on here, it actually will show you their login name. So this is user status, and here it will show you the MAC address, and in the version 2.2, it will actually show you their login name, so you can see. It'll show you their bandwidth. It's a great way for catching students who are using Kazaa. I wrote, a couple dozen emails to students who were using 600, 700, 800 megabits bandwidth, asking them to please have some consideration, and it worked every time. Didn't have to do very much. So that's the user status screen. This is one of the reports that's built in. They've got some really great reports. This is the very detailed usage report by user. The user who's connected to the system tells you the time they connected, where they connected, how much bandwidth they were using. It doesn't tell you what they were doing, which is fine. I'm not interested in that. And then from this, I was able to actually copy and paste this into Excel and into Access and create some of my own reports, which you'll see in a second. Daily stats. Here's the daily stats by access point. Tells you the total number of unique clients for that particular 24-hour period. So this particular classroom had 242 connected clients on this particular day. Total bandwidth used on that particular access point. And then they have graphs built into the software. So this is the daily usage starting at a little bit after 7:30, going until when we close the library, a little bit after 11. And you can see that at the peak point, which is about 1 o'clock in the afternoon, close to 300 clients connected concurrently. And here's one of the graphs that I use. This showed me because when I convinced the senior staff that we wanted to do this, I wanted to keep giving reports on the usage. And this is the peak weekly, daily usage. What I mean by that is each of these graphs shows the number of students who connected on a day, and it was the highest point in that week because we dropped off. Monday and Friday were always drop-offs, but Wednesday and Tuesday seemed to be very high. But you can see at the beginning of the fall semester, we had 50 students connecting to the network, and by the end of the spring semester, we had 425 students. That's out of a student population of 1,250. And that, I don't know what anyone else's experience is, but this just blew my mind when I saw that a third of the students on a daily basis were using the wireless network. And another graph I have shows the percentage of students, the total percentage, and we were up to, by the end of the spring semester, 60% of the students were using the wireless network on a regular basis. This graph just shows me by location, and this is the spring semester up to a certain point, the number of unique clients in any one location. And the last two bars here, which you can see, are the library. And to me, that was justification for all the work we did, because it showed me that the students were using it where we were hoping they were using it, which was the library. Now, costs. Everybody wants to know about costs. These were our costs a year ago. I'm going to show you the current costs. Airwave has changed their pricing structure. They had been charging their license of their software on a per AP basis, and they are now charging on a per server basis. But you can see here the Bluesocket server, the Airwave server, my access points, the Airwave license, and then the cabling to the Ethernet cabling to each access point, all that's figured in, and the wireless cost per AP, which is you can also translate to per classroom because we have one AP per classroom, was $1,318. Alternatively, we could have wired Ethernet into each of our classrooms, which is something we've been putting off because we didn't have the money, because that cost would be around $20,000. So costs currently, with the current model that Airwave is using for their pricing on their software licensing, the cost per classroom still is under $2,000, and the cost of the wired classroom again around $19,000, so about a tenth of the cost. That was one of the things that convinced our administration to go ahead with this, was showing them that the cost effectiveness, 10% of the cost per location. Questions we've faced. A lot of questions about where wireless and why wireless, and I've come to the conclusion that, and I think this is probably standard, is that wired is not going to go away. Wired is the best solution for stationary equipment, and wireless for mobile users, and it really has been proven out with more than half of our students within 1 year using wireless, just having it available and going out and getting cards. It was a mad rush. Questions about the pedagogical use of wireless, and I think that this has been mentioned today, certainly in the plenary this morning, and I think this is one of the really important questions, and this was the hardest question I had to answer when I was trying to convince the administration, and the answer that came to me from one of our distinguished faculty was that he said, anything that gets the students into the classroom is a good thing. At that point, it's my job as the teacher to get their attention. And that philosophy won the day. I was able to use that in my arguments with our dean, and we went ahead with the wiring of the classrooms. If we hadn't wired the classrooms, students still would have been able to pull in wireless. The signal strength would not have been as good, but and I think there would have been a lot of frustration on the students' part. Future of wireless. I think I'll let Greg talk a little bit about this. My thunder was a little bit stolen this morning when Tracy at the plenary announced, and I don't know if probably a number of people already know this, but last week 802.11g, which is our next standard, was finally ratified. So now we can look forward to the new products that will be coming out. And finally, lessons that we've learned. I think the importance of buy-in from the senior staff, making sure that your dean and your senior staff are behind you, informing them, letting them know what other schools are doing, and letting them know what the benefits for the students will be. The ubiquitous computing comment. There's a phenomenon happening, and ubiquitous computing, I think, is the best way to refer to it. Students are using notebooks in our classrooms. 75–80% of them are bringing laptops in. They have power to every seat. They use computer exams, and now wireless is the third prong. The final lesson that we learned is the importance of having good vendor relationships, partnerships, and that's my segue into introducing Greg, who will talk about some of the technical aspects, and because Airwave has been a great partner for us.
Thank you guys very much for taking the time to hear a little bit more about wireless today. I did promise Eric that I would not make this a commercial for Airwave, and I'd try and talk to you guys more about what we see happening in the sort of wireless space and how that affects a lot of our university and law school customers. We're a company, what we do is we develop wireless network management solutions. So you can think of us as a tool akin to, and we actually plug into an OpenView or a Tivoli, but specifically designed to manage RF wireless networks. And what I can talk to you today about a little bit of where we see wireless going, why wireless networks are so different to manage than wired networks. But I would say that the first thing that I would really give a lot of compliments to Eric, because sort of unique among a lot of our customers, Eric really took an approach that from the very beginning, I'm going to do a pilot of a wireless LAN, and it's going to be important for me from the very outset to figure out how I'm going to secure that wireless LAN, how the students are going to be using it, and what they're going to be using it for, and where we want them using it, and took a really proactive approach to thinking about how he was going to manage it. It's a very, very different matter to manage a wireless network if you're running a 5 or 10 access point trial in a library than it is to manage on a campus-wide basis. And not a lot of people, frankly, think about those things early enough in the process, and they let themselves get in a position where they're really playing catch-up and trying to figure out how to manage a network that's already too big and already overgrown. So if we think, I was back in my school days as a psychology major, and it probably stuck with me a little bit too much, but we think of the 5 stages of grief for an IT organization. The first stage being denial. We don't have a wireless LAN. I guarantee you, if you go around and you do take a net stumbler or a wireless sniffer, you've got a wireless LAN on your campus today, whether you know it or not. Faculty is deploying them, students are deploying them, they're there. You've got security concerns related to that, and also those access points are going to impact the performance of any network that you install. Second stage, anger. We're going to fire anybody. We're going to suspend any student who deploys an access point. That one usually lasts about as long as it takes you to figure out that the professor emeritus, the shining light in your faculty, is the guy who went out to the store and bought a $150 Linksys access point and plugged it right into your network behind the firewall. So typically that doesn't work very well and doesn't last very long. And then you get into the bargaining stage. Okay, let's control this. We'll start a little pilot. We'll put it in the library. We'll do a test in some public areas. And pretty soon what you find is wireless LANs, it's a grassroots phenomenon. As soon as you give it to someone, they want to start asking the same questions that Eric's students do. Why can't I have this in the classroom? Why can't we have it in the dorms? Why isn't it available outside in the dining hall areas? It's really, there's something that once it's introduced, it's very, very hard to contain. So you need to think about how you're going to control and manage that network as it gets much larger. And then finally get to depression. It's like, oh my God, how the heck are we going to manage this network if we're going to go from 10 access points today to 500 access points or 1,000, like some of our customers are. And then finally, acceptance. We've got to figure out a way that we're actually going to manage and control this. That's going to require that we spend some money, we get some specialized solutions like a Bluesocket or some other solutions on the access control side. You're going to need to look at management solutions from a company like mine or others. But you need to, just like you manage your wired network today, you need to invest in the tools that are going to enable you to control the wireless network and deliver the same levels of performance and reliability that you experience with your wired network today. And one of the first questions that we always get is, why is a wireless network so different to manage than a wired network? And the first seems so obvious it's hardly worth mentioning, but you're dealing with unlicensed RF spectrum. I was actually at a conference last week. It was amazing. They're sitting down with a bunch of folks from universities, some from enterprise, and they were all talking about, how do I protect my wireless airspace? How do I keep other people out? And it's unlicensed. It's not yours. You can't defend it. You can't tell who's going to be doing, who's going to be using that airspace. All you can do is monitor and control that airspace so that your network is responding dynamically to what's going on in the environment. You have the rights. You can control the real estate. You can control who has the rights to put up an access point and where on your campus or within your facilities. But that wireless network, the airspace itself, completely unlicensed, and you need to be able to adapt and manage and deal with that reality. The other thing I think is really unique about wireless networks is that they're much more subject to environmental factors than any wired network would. My favorite story is from a couple weeks ago. One of our customers is a hospital, and they were calling us saying, why is our wireless network that's cutting out every day at 2 o'clock? We can't figure out what's happening. There's nothing going on the network side. There's nothing we can see. And so finally, we sent someone out there and actually sat in their facility at 2 o'clock for a couple of days trying to figure out what was happening. What was happening is the flower delivery guy shows up at 2 o'clock every day at the reception area. The flower delivery guy brings Mylar balloons. The Mylar balloons were sitting up creating a shield around the wireless access point. So that's the kind of thing you got to remember. You're dealing with environmental factors that are going to impact the wireless performance. And you have to be able to, there's no way that you can prevent those Mylar balloons from coming into the environment. The key is having monitoring tools that are going to help you figure out what's going on so you can take some corrective action, which in this case was just as simple as saying, receptionist, can you maybe move the balloons to the other side of the counter? And that solved the problem, but there's no way to know that if you don't have good monitoring tools. Another thing that's very obvious is that you don't have any physical security on the network. I think a lot of us are reluctant to admit how dependent we are on physical security for our networks. If I walk into almost any corporate or campus facility, it's pretty easy for me to find a port, plug my laptop in, and I'm on that network and can do all sorts of things. We rely on the fact that physical access is controlled. Wireless networks remove that protection. And so I can access your network from anywhere where I can get in range of one of your wireless access points. So now you need to really start paying a lot more attention to access control solutions. That's where companies like Bluesocket are particularly strong. Who should be allowed on my network? What kinds of privileges should they get? And how should I deal with someone who's not authorized on the network? Another factor that's really critical is, unlike a lot of the wired networking technologies, this is incredibly low-cost hardware, very cheap, very easy to deploy, which makes it very easy for your communities to start deploying their own networks. And they can do it whether you want them to or not, and if they really want to, I can guarantee you get one of our engineers, he can put a wireless access point and he can hide that on your network, so there is no way you are ever going to see it from the wired side. And you need to think about what that means and what security policies you want to put in place and what security requirements you have to defend against that. Another thing that's really, again, obvious, but that users are mobile. The usage patterns that you're going to see are going to vary much more dramatically than they would on a typical wired network as users move. Eric was showing you as they go into and out of the library, into and out of the lunch areas. You're going to get clusters of users and much more dynamic usage patterns than what you're used to on your network, and you need to make sure that you've designed your network to accommodate that and that you've got the monitoring tools to be able to tell you where is your network being overtaxed right now, where is it being underutilized, so that you can continually refine and optimize the network and get better performance. And then finally, something that I think is really, when we talk about the future of wireless LANs, it's going to emerge as a much more critical issue, is the fact that you are dealing with relatively restricted shared bandwidth. So 802.11b, theoretically 11 megabits per second, realistically 5.5 maybe. 802.11g, theoretical 24, realistic 11, 12. But as more and more users, you've got fixed amount of bandwidth that's available through that access point, more and more users coming onto that network. As more students get enabled, more laptops, more handheld devices, wireless voice over IP telephones coming along very quickly. Over the next 3 or 4 years, dealing with and managing and balancing the load among your access points is going to be increasingly critical. The 802.11 standards themselves are dumb. If you think about the standard today, if there's a wireless access point in this room, all of us are going to associate to that wireless access point because we're seeing the strongest signal from it. That may be fine if there are only 5 or 6 of us who are out there, or there are a lot of us who are using relatively low bandwidth applications. But if there are many of us who are using high bandwidth applications or we've got quality of service requirements, the optimum isn't going to be have all of us associated to that one access point. It's going to be disperse them to all of the available access points, everything that we've got within range, to try to manage and control that load. That's something that I don't think is at the forefront of a lot of people's thinking today while wireless LANs are kind of in their infancy, but it's something that's going to be increasingly important as wireless LANs become sort of the core mission-critical network at a lot of institutions. And so think a case study, and I did check to make sure that no one from this particular university is in the room today. This is one of our customers who had a network of about 500 wireless access points across 37 buildings, 2 million square feet being covered by those wireless access points. When we went out and did an audit with them, what we found was the IT organization couldn't do what Eric did. They couldn't tell us how many users were on their network at any given point, how many users they'd ever had on their network. So they were completely flying blind. All they knew is that they had deployed 475 access points. They'd actually gone to the length of specifying a configuration policy for our access points. WEP should be enabled. The broadcast SSID should be disabled. We're going to use the following transmission strength and the polling intervals. We went out and did an audit. More than half of their access points violated their own configuration policy. This is typically because enterprise access points have up to 200, 300 variable settings. Very easy for someone to make a manual configuration error, or as someone, one of your own employees, goes out and makes and tries to fine-tune the network, very easy for them to configure that access point out of compliance with your policy. Worst thing we found for their perspective was that of those access points, 35% of them had absolutely no security. So they were supposed to have encryption enabled, they were supposed to be using a particular authentication source. 35% of them were running absolutely wide open. They had no visibility to that. Another thing we found was that 10 access points were non-operational. It was the scenario that Eric described. You could actually ping the device, you could see and it would respond, but no one could associate to the access point. The only way you found it was by looking at the usage pattern and saying, hey, wait a minute, this access point is surrounded by 9 others. Each of them has had 50 users over the past couple of days. This one's got nothing. That seems a little unlikely. Let's go investigate that and find out what's going on. But they didn't have that, and their best guess was that they'd probably been non-operational for about 6 months. They found that 7 of their wireless access points that they had deployed were completely missing. They couldn't find them. They just assumed that a student had crawled up and disconnected the access point and was now providing wireless connectivity in a dorm or in an apartment complex. But they just couldn't find it anywhere. None of their access points were running the most current firmware versions, which was particularly significant because they had missed 2 of the most recent security patches from their 2 predominant vendors. And the reason they didn't do these firmware upgrades is because it's too difficult. Going access point by access point, just way too time consuming, and so they hadn't done that. They hadn't done a firmware upgrade since they installed their network. And then we found in just one of those buildings in the medical school, 10 rogue access points, which is kind of interesting because the medical school is providing wall-to-wall wireless coverage internally. So I said, why in God's name would these people go out and deploy their own wireless access points? Well, they didn't want to share the bandwidth with other people. They wanted to get better coverage in the dining area, or a professor had coverage in his office, but he didn't have quite enough coverage in his lab. So they all went out and they went to Fry's Electronics and they bought $125 access points, never told IT about it. So that's typical, and I think you just have to be aware of those, both from a security perspective, but also from the fact that those access points now interfere with the network that you are trying to manage, monitor, and maintain for yourself. And that's really where we think wireless network management software solutions, like the one that we create, come in, is providing a management layer that handles all of the RF-specific configuration and monitoring, and does that in an integrated way that integrates with the rest of your existing network infrastructure. There are some solutions out there today and some people who are viewing their wireless network as a completely standalone network, and they're buying proprietary systems and a lot of proprietary hardware, which strikes me as really crazy. What you want to do, and my recommendation to everybody, is figure out, take an inventory of what you've got on your network infrastructure and figure out how you can leverage that and apply it out to your wireless network. Don't build completely redundant infrastructure, but use what you've got. It's going to be a lot more cost effective for you. And when we think about wireless LAN management, the essential components is what Eric was describing, having visibility so that you can monitor everything that's going on your network. You can see all of the users. You know what signal strength they're seeing. You know all of the access points on the network, how many users are associated, what kind of bandwidth they're utilizing through that access point, and that you be able to take action on a centralized basis so that if I need to take any corrective actions, I can do that without dispatching a technician out to reconfigure that access point manually. And an area where I think the industry, and we in particular, are spending a lot more time is automating more of the diagnostics. If you can see what's going on, you can take automatic action so that you optimize the network performance. So a couple examples of that kind of thing. Today, with access point configurations, one of the things that we do is we actually go out, we know what your policy is, how your access points are supposed to be configured, audit that, and compare the actual configuration of the access point with your policy, and auto-repair it. So that for whatever reason, your access point gets out of compliance, you can automatically reset it and know that you're not going to have any performance or security vulnerabilities as a result. Another thing that people start to think about, if I see, I'm monitoring my wireless network, and I see that 5 users on a particular access point have a very poor signal, what am I going to do about that? Well, long term, I may want to consider reconfiguring my network, adding more access points, providing better coverage. Short term, what I probably want to do is try increasing the transmission power from that access point, see if I can get them a better signal. That's the type of thing that can be done on a centralized basis today, and tomorrow, in the near future, will be automated so that you've got a dynamic tool that's constantly fine-tuning and adjusting your wireless network to achieve optimum performance. And that is really critical when you think about very dynamic networks that are subject to very variable usage patterns and to environmental factors. And other issues, like Eric and I were talking about earlier today, one thing that not a lot of people have recognized is that if you move over to 802.11g and deploy with these higher throughput access points, if you have a single 802.11b user who associates with that 802.11g access point, it's going to bring down the throughput available to all of the other users to 802.11b levels. That's horrendously inefficient. So if I've got 10 people who have 802.11g enabled cards associated to a wireless access point, and one student moseys in there and associates to that access point with the B card, everyone else is affected. What you want are going to be solutions that enable you to do load balancing shipping so that you can say, hey, that user, that 802.11b user, shouldn't be associated to that access point. I want him on another access point that we've designated as primarily for 802.11b users, or where there's no other 802.11g users associated. So that, I think, is something that is going to be implemented over the next several months, years, is going to become more of an issue as network load becomes more of a problem on wireless networks. Another thing that I really wanted to talk about, because we get questions all the time about what is the relationship between network management and wireless network security. And people sometimes talk about them like they're completely separate topics, when in reality they're just two sides of the same coin. If you can't manage your wireless network, if you can't manage the configurations on all of your access points, then you've got to assume that your wireless network is wide open and unsecure. So when we think about what do you need to do to secure your network, the first thing you need to do is be able to discover what's on your network, know what's out there, make sure that you know exactly how many wireless access points there are, what they're doing, how they're configured. When you get down to the next level, management, be able to control those configurations, make sure that they comply with the policies that you've established. Once you've taken control, you've got the basic control of the network infrastructure itself, then you can start thinking about addressing some of the issues where companies like Bluesocket get involved. Of how am I going to deal with access on this network? How do I determine what level of access I should permit to students versus faculty members? And do I want to do different levels of access depending on time of day or location on the network? Those types of things I think are very critical and are things that I know all of you are wrestling with. And then on top of that, encryption. What kind of encryption do I want to use to protect the data as it's going through the air? There's some standards-based solutions that are emerging. We'll talk a little bit about 802.11i, which is coming out, hopefully going to be ratified by IEEE this fall. Already starting to see some vendors sort of pre-ship product that is 802.11i compliant. That's going to solve a lot of the encryption problems that have afflicted wireless networks to date. But whatever encryption solution you use, whether you use a VPN-based solution, whether you start implementing more standards-based encryption, you need to make sure that that is operating in concert with whatever management solution so that your access point and your infrastructure is configured properly to accommodate and support your security policy. And then finally, make sure that you've got a solution in place to continuously audit the settings, continuously audit the network to ensure that it remains in compliance. Because again, it's not enough to do a one-time site survey and think that you've got your wireless network defined and coverage is now taken care of. It's not enough to make sure that your access point is configured properly on day one. Those are things that you need to do on an ongoing basis and implement automated and have automated tools that do a lot of that work for you. So I probably don't need to go into a lot of detail here, but first I really do urge you, make sure that you find solutions that are going to enable you to take an accurate inventory of your network so that you know not just what wireless access points have I deployed, but what wireless access points have other people deployed on the network. And then which of those wireless access points do I want to authorize? Which should remain on the network? Which ones should be removed? And once you figure out that, assign management responsibility so that you can define from this point forward who has the rights to manage that access point so that you know you're not vulnerable to any malicious intruders or people coming in and changing the settings on the access points in a way that you're not comfortable with. Another thing, I really want to go into a little bit more detail about rogue access points because it really has emerged as kind of the critical issue for a lot of education and a lot of corporate customers. And so with my apologies to George W. Bush, we sort of categorize the threat from rogue access points. Severe is obviously a malicious rogue. If my sole purpose is to get onto your network and deploy a wireless access point that you can't find, what I'm probably going to do is I'm going to take that access point and I'm going to configure it so it looks just like a hub. So you're never going to find that through any mechanism other than wireless scanning. So one critical thing that you need to look at and make sure that you've got is the ability to conduct regular wireless scans. Some people try and do that today with wireless sniffers, handheld devices. what we've actually, the sort of innovation that we've introduced is use your existing access point infrastructure to scan the RF environment and report back on what's in the area, and then make intelligent determinations about what should be there versus what you actually found. But that is, one point, if you don't have an RF scanning capability, you cannot be guaranteed that you are going to find all of the wireless access points that are on your network, because it is very easy to hide a wireless access point. Another, that we find is probably the most common types of roads are ones that are deployed by well-meaning students or employees, and they're not specifically deploying a wireless access point to open a breach or hole in your network, but they're going and trying to put an access point out there for their own personal use, but typically they don't enable any real security settings on that. So you want to find there's some things that you can do from the wireline side so that you can go out and ping that device, and once you identify if there's a new device on your network, start interrogating that device so that you find out and see if you can get it to respond in a way that will reveal to you that it's a wireless access point. So that is a technique that you can use whether or not that rogue access point is in range of some of your existing RF scanners or not. And another thing that I think a lot of people lose sight of that's very relevant in Eric's kind of an urban environment is that you've got to be concerned not just about the access points that are connected to your own network, but other access points that are using the airspace. So that is obviously because it's going to cause interference problems on your network, but one of the most common attacks that we've seen with some of our public ISPs are people who are trying man-in-the-middle attacks. Someone who puts a wireless access point and tries to configure that access point so that it looks like a legitimate access point and fool users into associating with that access point and stealing information from them. If the access point's not connected to your network, there's no way that you're going to see it, again, unless you're able to do some wireless scanning so that you're aware of all of the other radios and all of the other devices that are within range that are using the same airspace that you are. And then, dealing with the configuration errors. Talked about this, and typically the problem is human error. The impact is that it could completely strip away any wireless security that you've implemented. Best case, it's going to start interfering with network performance because that access point is not going to be controlled and configured in a way that is optimal. What I would really urge is whatever you do, whatever solution you implement, make sure that you've got a solution that has an audit capability that can go out and scan your existing infrastructure and identify for you whether that infrastructure complies with the policies you've established. And then just when you think about it, we get a lot of questions about security. What level of security should we be using? What settings should we enable? And there's, a lot of people have talked about WEP, the sort of basic security standard, the initial one inherent to 802.11b. It's a very flawed encryption algorithm. I wouldn't particularly want to rely on WEP myself, but it's definitely better than nothing. If you have a choice between running a completely open access point and using some encryption, definitely recommend that and making sure that your entire infrastructure has WEP enabled. WPA, which has actually been implemented now in products that are available, takes WEP and makes it as secure as WEP can be. It does dynamic key exchange, it uses 128-bit encryption, so it makes it much more difficult for people to steal the keys. Still not flawless. 802.11i, which is to be ratified later this year, moves over to AES encryption, which is going to be much more secure. And I would definitely recommend that you look at making sure that you're buying an access point and a hardware infrastructure that is capable of taking an 802.11i upgrade. Do you have a question?
Is what WPA, is that the same concept as Cisco's Leap?
Oh, Cisco's Leap is an entirely proprietary solution. So
But the same idea with the dynamic key.
So similar idea, different encryption algorithms being used, but yes, very much a similar solution. But WEP is, or WPA is standards-based solution. Leap is not standards-based, so you need to make sure you've got Leap-enabled clients as well as access points. And then, making sure one thing that is really critical is making sure that whatever your authentication policy is, whether you're using a VPN, whether you're using a gateway device, that all of your access points are routing the traffic to the right point, that you've got VLANs set. If you're using VLANs to route the traffic, that those are configured properly, and that means that all of your access points have to be configured in a way that complies with that policy. Other things, I think where we find the most common configuration errors or problems on network, people who don't specify or don't control the SSIDs or use the same SSID across campus and never change them. If you've got a security policy, typically good practice in your more secure areas is to make sure that you rotate the SSIDs on a relatively frequent basis. Again, Eric already mentioned you want to make sure that your channels are allocated properly so that contiguous access points aren't interfering with one another, and making sure that you've got the transmission power set appropriately for the coverage that you're trying to achieve. Again, having a real user-based monitoring solution so that you can tell where is my network being utilized, where are dead zones on my network, where do I have access points that are most utilized. This is from another university, but you can see the same pattern that Eric saw. Students getting up at around, well, not until 10, and then going to lunch, and then have the access drop off, and then spikes right in the early afternoon and gradually trails off throughout the day. Very, very different patterns across the network. Obviously, this is a pattern that would be fairly typical of some of the academic buildings. Dorms look completely the opposite of that. You've got to be aware of, make sure you're monitoring when is the peak usage, and is my network optimized for peak usage at all of these various times. Proactive network monitoring. The simple observation that I'd make here is with wireless networks, you don't want to take a simple event-based approach to monitoring a network of just receiving an alert when something goes wrong or when a simple event occurs. What you need to have is solutions with synthetic triggers that are going to enable you to say, hey, it's not necessarily a problem if I have a minor blip in signal strength. So the Mylar balloons walk past my access point, so for 10 seconds, all of my users got poor signal strength. What you want to be alerted to is, do I have a sustained signal strength problem where multiple users are seeing low signal strength for an extended period of time? That's when I want to receive an alert. That's when I want to do something about it. And then, probably the most common question I get from folks in your position is, what do you recommend for me in terms of the hardware choices that I should make? If I'm looking at wireless access points, there are dozens of different vendors. What selections should I make? From our perspective, it really doesn't matter. We are, as a management solution, we made the choice early on that we're vendor agnostic, so we support access points from Cisco and Proxima and Terasys and Intel and Symbol and all of the major suspects. 3E, which is another company that Eric mentioned. But the thing that I would really urge you to do, make sure that you're buying an access point that is SNMP configurable and SNMP manageable. A lot of the low-end access points that you might buy, the cheapest ones you can see for $100 or less, they're not remote manageable. And that's going to mean that as your wireless network gets larger, you're going to have a real bind because you're going to have to go access point by access point to make any kind of configuration changes or updates. So that is my bare minimum requirement. I think you'd be crazy to do anything other than that. The other thing that I'd really recommend is select an access point that has wireless scanning capabilities. This is something that not all access points have today. Cisco has actually indicated that they're implementing it in June. I think it's on Proxima's product roadmap for August. Intel and Symbols do it today. But that's really going to be something that is critical to managing and monitoring your wireless network, is the ability to use your existing access point infrastructure to scan the RF environment and figure out what's going on and use that as a troubleshooting tool. So not all access points have that. It's something that I would really recommend, and it's going to get more critical as wireless networks get more used. Another thing, know what your client base is. Know how many users you're going to have, what kind of bandwidth utilization they're going to need. My personal recommendation is aligned with Eric's. I think 802.11g is a great choice, especially when you look at the student environment, students buying Dell laptops, other things, with 802.11b radios embedded. There's a huge existing embedded base of 802.11b devices out there. So selecting, and right now, frankly, migrating over to 802.11a would leave a lot of the student base behind, a lot of the client device behind. I think you can probably achieve, with appropriate management of the infrastructure, you can probably achieve the levels of performance you're going to need with an 802.11g infrastructure. Again, make sure that you look at an access point that is remote upgradable and that has the processing power and the memory to handle an upgrade to 802.11i, because I suspect that as that standard is ratified and enabled, that a lot of you are going to want to migrate in that direction for data encryption. It's going to eliminate a lot of the requirements for proprietary client software. It's going to make your networks much more secure. Again, that's going to be ratified later this year, but the major manufacturers are already taking steps to make sure that the access points and client devices are going to be capable of supporting that via a remote upgrade. And last, the thing that I think is really critical is use access points that are standards-based. There are some proprietary solutions out there right now, some solutions perhaps where an access point might only work if it's used in conjunction with a a particular wireless switch or an end-to-end proprietary solution. There are some good companies out there. My observation is there's a lot of commoditization going on in the hardware space right now. There is going to be a shakeout, and the last thing in the world I would want to do in your position is go out and buy a hardware infrastructure from a provider who may or may not be there, or may or may not be in the business a year or 2 years from now. So the market's in the early stages. I would say caution dictates go with some of the major providers who've got SNMP manageable access points that you'll be able to use and control for years to come. So with that, throw it open to any questions any of you guys might have. Yes, sir.
How do you deal with a situation where you would have a need for more than 3 access points in a small area with the overlapping channel issue?
What I would do is I would probably look at, just say, at the RF design. I might use some of the other channels to, there's be some bleed over, but it'll be less if you space the channel allocation out. I would also then take a look at what is the transmission power I'm using from the access point. If I've got a very dense environment that's going to have lots and lots of users, I may not need each one of those access points to be providing 150 or 200 foot radius of coverage. If I narrow the coverage down, I'm going to cause less interference from access point to access point, and I'm going to be able to support more users within the coverage area that I've defined. So there's a mix between sort of the channel allocation and the transmission power, and I would play with it and tweak those variables until I got it right. So that's one of the things that I would observe, is that you're never going to get it right at first. So you want to make sure that you've got management solutions that are going to allow you to say remotely, I used to have access points, and it used to be appropriate to have them configured on these channels. Now we've introduced other access points, we've got different usage patterns. I want to change the channel configuration and mix it up. You want to be able to do that on an automated, very efficient basis.
So does your software work with the pre-Proxim Lucent access points?
Yes, it does. It works with the Proxim. Actually, Proxim access points and the Lucent access points are available under all sorts of brand names, from Dell, Compaq, Avaya. They like actually some of the early Apple access points as well.
We adopted fairly early, and I've been doing wireless, and I'm the person that really needs to do desperately something like this. But I also said, I'm kind of nervous to hear that you went down the SMTP route. I know there are a wealth of tools out there that can grab onto that information. Aerial, just to name a couple off the top of my head, that can do incredible things with that data by taking that particular protocol. And when I look back, I've been doing this about 12 years, I've almost concluded that in some cases you really want to step away from the standard so early, because you have a kind of odds game you're playing that not as many people are going to know that. And Cisco comes to mind immediately for that kind of reason. So I guess I'm a little bit nervous to hear you say that. On the other hand, I'm the person to say, yes, it sure is easier to buy things when you go into SNMP.
Right. Yeah, I think the SNMP for management is the most common. We have to manage devices. We said as a third-party vendor-agnostic solution, we have to manage the device through whatever means that device can be managed. And frankly, with some of the access points for all of the variables, you need to use a combination of SNMP and HTTP. There's some variables you can only get to through HTTP. There are some access points that have come out very recently. They're supporting SNMP v3. It's more secure. We're really, that is something where third-party solutions like ours are at the mercy of the hardware manufacturers. We can only manage it by whatever protocols they're supporting on the hardware side. The vast majority of them, of the enterprise class access points, are SNMP managed today.
One quick follow-up, sorry. What's the real overhead to make this kind of thing happen, to make the transition? How long is this kind of product you can learn over a weekend and get it deployed? I mean, is this?
Oh, I would say so.
Right.
Very easy.
Yeah. Typically, the software, our software installs, it's usually network administrators spend a morning doing the installation and some training.
Has anybody complained about human carriage with high radio frequencies?
I have not heard anyone. I have not heard complaints about that. I know that is actually one of the primary concerns early on for 802.11, especially in the healthcare environment, was is this going to have any kind of impact on the humans and health? I haven't heard anything, and in fact, probably the outside of higher education, which is where probably a good 40% of our customer base is, the leading vertical market and the leading adopters of wireless technology are hospitals themselves and healthcare organizations. They're actually under a mandate. I think it's by the end of 2006. They've got to be able to do barcode scanning at the point of pharmaceutical dispensation, which means bedside in the hospital, which means they either pull lots and lots of cable or they go wireless, and so hospitals are going in droves over to wireless deployments. So, I'm sorry.
At Hastings, did they address the issue within the classrooms? I'm assuming that a lot of the classrooms in that small building are conjoined as far as limiting or disabling the internet access during periods that the professors deem they don't want internet access in their classroom?
Right. Well, the first, that building, the classroom building, was renovated 4 years ago, and we renovated all the classrooms, put power to every seat, which is one of the problems with putting in this stuff. And we wired one classroom, and what I did is I actually installed a switch. We had a separate hub stack for that classroom, and my switch just turned the power on. And we found faculty, a few faculty would use that. So when we put wireless in, we got that question, can I turn it off? And I said, unfortunately, no, you can't, because the large reading room facility, for example, you can be on the top floor and pick up signal from the access point on the first floor, but have to turn off the whole building. And I have had no complaints from faculty. Again, I use that same, the paradigm, whatever gets them in the classroom is a good thing. I use that whenever there's any discussion, and we talk about the uses that students are making. Mostly it's checking email, doing web stuff, but some of the students have come up with some interesting things. And what we also found is faculty who use their web pages in class, students will hold those up on their computers in order to get a better view of those small fine print or graphics. And so it's a real open question.
Our campus at George is looking at deploying, and that was one of the requirements from faculty was that not only would we be required to accommodate every seat in the classroom,
right,
but also be able to restrict every seat in the classroom, even though the classroom next door has theirs on.
right. What I would probably suggest, we actually do have some customers, and you have the ability with the software, you can control and schedule the radio to be disabled at a particular time. An issue that Eric raises is that you've got RF issues, that there's bleed over from one access point to another, so you need to make sure that you're controlling. If your goal is to be able to use that functionality and really provide blanket coverage, you've got to do a really good job